Hi everyone, good morning. I'm Christina Daly from the Department of ECE. Here in this lecture series, we are going to see about the semiconductor diodes and their applications. Before entering into the topic, the first thing we have to know what do you mean by a semiconductor and what are all the diodes we are having, how the diode works in the forward and reverse bias conditions. Here the contents is given. The first one is the introduction, unbiased PN junction diode, forward biased PN junction diode, reversed biased PN junction diode, mechanism of breakdown, then the characteristics of PN junction diode. These are all the things we are going to see in this lecture series. So the first one, we have to know what do you mean by a PN junction diode. Here the symbol of PN junction diode is given. It consists of two terminals. One is positive, another one will be negative. Positive is represented as anode, negative is represented as cathode. Here we are having two types. One is P type, another one is N type. Both P type and N type together formed, hence it is known as PN junction diode. The majority carriers in the P will be holes and the minority carriers will be in the N type as electrons. So this is the symbol of the PN junction diode. Next, we are going to see how the PN junction diode works in an unbiased condition. Here, it represents the forward bias as well as reversed bias. There is only one difference according to the forward bias and the reverse bias. So, what is the difference means? The positive terminal is connected to the anode and the negative terminal is connected to the cathode. So, this is forward biased. At the same time, when the negative terminal is connected to the anode and the positive is connected to the cathode, this is called as reversed bias. So in this unbiased PN junction diode, we are having two types. One is P type, another one is N types. So here when the supply is not given, when the no external force that has been applied, here the holes present in the P type will be moved to the N type and the electrons present in the N type will move to the P type. So at that time a region is formed due to the electrostatic field. So that region is termed to be as the depletion region. So here in this diagram, the P type has majority holes and the N type has minority carriers. So when the electrostatic field is applied, both the holes and the electrons, that is free electron as well as the negative ion and the positive ion moves, so that at the time a region is formed that is termed to be as the depletion region. Here we are going to see how it works in the forward bias condition. When the positive terminal of the battery is connected to the P type and the negative terminal is connected to the N type, this is known as the forward bias. So here in this diagram, we are going to see the holes present in the P type and the electrons present in the N type. So while the supply is given, automatically when the positive is connected to P type and the negative is connected to the N type, automatically the holes will move to the electrons and electrons will move to the holes. So here the W is represented as the depletion region. So while under the forward condition, we are going to see the potential. So when it rises from 0, it will be in the increased order and after that it will be in the constant. So this is given during the forward bias condition. So while the reverse bias condition, when the negative terminal of the battery is connected to the P type and positive terminal of the battery is connected to the N type of the PN junction, the bias applied is known as reverse bias. So here from the diagram itself we can see the negative is connected to P type and the positive is connected to N type. So this is termed to be as the reverse bias condition. So this is the representation of the reversed bias, as the connection is same but the terminal that has been connected will be in the reverse condition. So this is the characteristics of PN junction diode. So here we have analyzed the characteristics for that is voltage and the current. So here we are representing the positive as forward voltage and the negative as reverse voltage, positive V and negative V. The current, it will be measured in milliamps, that is positive, that is forward current and the reversed current. So here while applying the voltage, the first thing it will be in constant. So when it conducts means for germanium it will be 0.3 volt, for silicon it will be 0.7. So that is termed to be as the knee voltage. So when keep on increasing the voltage, the current get increased. So that is termed to be as the forward bias. So here in the reverse voltage, so while the current is constant, at the same time it drops. So that is termed to be as your breakdown region. So this is termed to be as your reverse bias condition, and this is the characteristics. So mechanism of breakdown, we are going to see two types of effects. One is avalanche, another one is Zener. The difference between the avalanche and Zener is, in avalanche it is slightly doped semiconductor and the carriers are generated by collisions and the breakdown voltage is high. So it is a reverse operation of the Zener effect, where it is heavily doped and the breakdown voltage is low. So these are all the assessment questions. Thank you.